Okay, let us come to another example. Fx is equal to 1 by 7 x to the power 4 minus 3x square plus 25. Is it polynomial?
Yes.
No,
Yes,
sir.
sir.
No, sir.
Yes or no?
No, sir.
Yes, sir.
Somebody is saying no.
Yes, sir.
Hmm?
Yes, sir.
No, only you judge the power of the independent variable. You check the power of the independent variable.
Minus power.
Here is what you said. Yes, it was a technical question, but you gave the right answer. It is, I write here x naught. Okay, so this 0 is what? Fractional? Not fractional, non-fractional. And this is what? Integer, non-negative integer. Is it non-negative integer? Yes.
Yes, sir.
So it is non-negative because the 0 integer, positive integers and negative integers. So only restriction is that this is a particular function. Function is a particular kind of, polynomial is a particular kind of function where it follows the restricted conditions. And these restricted conditions are the power of the independent variable involved in the function must be non-negative integer and must be non-fractional value. So in both of cases, we have tested this is not, because this involves the fractional value, that is half, and from that point of view this is not a polynomial. So this is a polynomial, yes. And now next, this one, fx is equal to 3 plus 1 upon x. This is
No, sir.
no.
Sir, not polynomial.
Why? Because
Sir, x the power, sir, x power negative.
X की power minus में होगी.
yes, this will involve, I am talking about 4, this will involve the negative integer. So the difference between polynomial and function is what? All the functions are not all functions implies like this, you can say. Functions and this symbol. This implies this gives the polynomial. But if you put here polynomials, polynomials, so always this is not true.
Function.
I mean to say these are called polynomial functions. Therefore, the name is called the polynomial functions. The polynomial functions. Polynomial functions. They are polynomial functions. If you remember, while discussing the concept of interpolation, this polynomial, which was approximated by the function, from the function, this was called, name was what? Interpolating polynomial. Interpolating polynomial. Interpolating polynomial. And this polynomial was called what? Method of interpolation. Polynomial interpolation. So polynomial will play a very important role because of this convenience, mathematical convenience. If in a single line difference, why we made like this? Why we defined the polynomial? Why we approximated the complicated function to the polynomial? In a single word, we can say this was simply for the mathematical convenience. I told you mathematical convenience. Why we will get the mathematical convenience? Because the mathematical tractability, what we do, mathematical tractability is most important. Tractability. Mathematical tractability is most important. Tractability means it's a handling. Tractability is most important. When you cannot apply your function and the solution of the function is very important, but we cannot solve it. We cannot analyze the nature of the function. As we discussed, if you remember, What was the problem of the complicacy? Why we come to polynomial? This is the convenience. It was convenience for the mathematical treatment or for the mathematical practice. And why the function was complicated? Do you remember this point? Why the function was complicated? The function was complicated because of its implicity. If you remember, explicit function, and another was implicit function. Implicit function is very difficult, and many of the discussions we do not face the problem of the implicit function, because this implicit function is very difficult to solve, because the independent variables or the arguments in the context of numerical analysis, this is not separated. This is not separated from the y or dependent variable, and therefore this becomes very difficult to solve. So somehow we manage to approximate the function so that we can get the solution of the polynomial, and we can handle the mathematical tractability of the polynomial because of these simple conditions. So polynomial is a conditioned function. What we did, polynomial is a conditioned function. One line definition is polynomial is a conditioned function. Conditioned function. Nowadays we are conditioned. What condition is? That you remain in the house, remain safe in the house. So we are conditioned. We can't go anywhere. So we similarly, the polynomial is a conditioned function, and function has gone under the conditions, and these conditions are the power of the independent variable won't involve non-negative integers and fractional values. That's all. So if we try to summarize from very beginning, if you look at what we did, we started from the means of, from taking back you to the concept of the interpolation, because we had the advantage of the interpolation. We had the concept of the approximation of the function by estimating the values of the function for corresponding given values of the independent variable in a particular range. And that time we came to the concept of the polynomial. The function is approximated. If you remember, I had shown you the book of Professor Rao that second advantage was the function, the complicated function was made simpler. This was transformed into a simple form of function that is nothing else but the polynomial, and that can help to approximate the value of the function very easily. And therefore it becomes very important to discuss the difference between the polynomial and the function. So we came to the concept of the polynomial and function. We discussed with the numerical examples, and we came to the conclusion that function is a broader concept as compared to polynomial. I mean to say the polynomial is nothing else but a conditioned function. When we impose certain conditions on the functions, then function turns to be a polynomial, and these conditions are what the function which involves the independent variable, if that independent variable possesses its power in the form of non-negative integers as well as in the form of the non-fractional values, then and only then the function becomes the polynomial. And after this lecture, since today is enough time, I will start tomorrow a very important and fundamental result that we discussed the operators. If you remember, we discussed the differences, the 6 important kind of differences we discussed. If you remember, the first one was the forward difference, the second was the backward difference, and then to the central difference, which came shifting differences, shifting operator, then the averaging operator, the differential operators. So in which we analyzed the function. But one important point is when we talk about polynomials and without the polynomials, the approximation of the functions is not possible, as we have seen. Out of this discussion also we came to this concluding remark that without the study of the polynomial, the approximation is not possible. But so far we have not studied. I was asking you that I need to remember one very fundamental theorem, one very fundamental result, that the differences of the polynomials. We did not discuss the differences of the polynomial. Differences of the polynomial. Differences. Differences of the polynomial. Differences of the polynomials. Differences of the polynomials means the first difference, the second difference. If we write the polynomials, y, x is the polynomial. Suppose this is a polynomial, and this is the independent random variable, and it has degree. It has degree, suppose n. Then if we start taking the differences of the polynomial, what kind of results, what kind of findings we come across? That is very important. And this very property is used for finding or obtaining the missing values. Missing values, finding the missing values is very important discussion. Missing values. Find the missing values. Finding the missing values means 4 values of the functions are given. 4 values of the functions are given. Suppose here we are given y1, here we are given the y2 corresponding x2, we are given the y2, and thereafter we are given the y4, the y4, and we are given thereafter the y5, we are given the y5, but in between y3 is not given. Here look at the value of the y3 is not given. This place is corresponding to y3. So corresponding value of x1 we have got the y1, corresponding value of the x2 we have got y2, the x3 is given but y3 is not given, and y4 is already given, and y5 is already given, then how we can find the missing values of this y, I mean y3. So in this very property, finding the missing values, this was also a part of your course in your B.Sc undergraduate level. I remember that, though this was the part of when we were studying MSc, then it was the part of the MSc. But now this has gone up to the level of B.Sc, and this is the very fundamental. So these fundamental differences of the polynomial, the first difference, we talk about the first difference, the second difference, the third difference, the n minus 1th difference, the nth difference, then can we go for the n plus 1 difference or not? And what we will get after taking the nth difference? If degree is n, the nth difference is allowed or not? And if it is allowed, then what value we get? And if it is not allowed, then what value we get? So this kind of property we will discuss tomorrow. And after discussing these differences of the polynomial, we will come and lay down certain rules, certain property, which will be a working property or workable property, which will help to solve the problems of the missing values. So today is enough, I think. Any query, please? You can unmute.
Yes, sir.
Any query?
No, sir. सर फंक्शन पॉलिनोमियल हो सकता है?
हाँ, हो सकता है।
सर नहीं भी हो सकता है ना?
हाँ?
फंक्शन पॉलिनोमियल नहीं भी हो सकता है ना?
नहीं हो सकता है। कहाँ थे? अभी तो जो एग्जांपल दिया उसमें फंक्शन तो डिफरेंट है, वो सब फंक्शन है।
Function is polynomial, but every function is not polynomial.
All functions are not polynomial.
All polynomial is not function.
All polynomials are not. Perhaps I have this. All functions are not polynomials. This has been reversed. You make it correct. All functions are not polynomial. But all polynomials are functions. Now this has been wrong. You correct it.
This
All polynomials are functions. All functions are not polynomials. Writing this symbol may create the confusion. Language is very important. Here I would like to.
सर इसमें बड़ा लेट में शो हो रहा था, इसमें दिखाई नहीं दे रहा था जो आप टाइप कर रहे थे।
हाँ, इस समय दिख रहा है कि नहीं?
सर अभी दिख रहा है, लेकिन जब आप टाइप कर रहे थे उसमें कुछ नहीं दिख रहा था इसमें।
ऐसा क्यों?
सर पता नहीं, क्योंकि इसमें दिखी नहीं, जब आप टाइप कर रहे थे तो उसमें कुछ भी नहीं दिख रहा था। अभी जो है अब जो है शो हो रहा है y1 y2 फिर ब्रैकेट है, फिर y4 y5 अभी शो हो रहा है।
इस समय जो लिख रहा हूँ ऑल फंक्शन, ये दिख रहा है कि
ये
नहीं?
सर दिख रहा है।
हाँ सर ये दिख रहा है, सर ये दिख रहा है।
All functions are not polynomial. ये दिख रहा है कि नहीं?
सर रुक गया, हमारे में दिख नहीं रहा।
नेटवर्क प्रॉब्लम।
अच्छा, और बताइए, और दिख रहा है उन लोगों को?
दिख रहा है
यस
सर।
सर।
अच्छा,
जी सर दिख रहा है।
सर यहाँ पर खाली ऑल फंक्शंस लिखा हुआ है।
all functions are not polynomial. सब दिखा नहीं दिखा? all polynomial are
Function.
Not function.
Function.
all polynomials are functions. Ye,
Are
this symbol may create a confusion. I use this. You look, this is kind of eraser here. It makes a different color, then automatically this will go. Now this is important. All functions are not polynomials. And therefore these polynomials name is polynomial functions. They are known polynomial function. Polynomial function. Because basically this is a function, but under certain condition. When function is conditioned, this produces the polynomial. But all polynomials are functions. All polynomials, they are functions. And exploiting this property, taking out this property, we have come to the conclusion that they both agree at the tabulated data. Do you get this point or not? They both agree at tabulated data or given data. Agree means whatever the value they get after estimation, the value agree. I mean, there is no major difference between them. If you are a my student and I am your teacher, I have taught you, you have learned it from me, then the learning, the amount of learning, your amount of learning is my approximation, my learning, approximation of my learning. So when you are somewhere stood and I am not there, then whatever you are doing, that is my approximation. I mean to say, whatever you express and whatever I express, both are more or less same. So when I am conditioned, I reproduce you. I reproduce you. You represent me. Just like this one. I am conditioned to prepare you. Similarly, the function is a broader concept. When we undergo this, when all functions undergo and they, if satisfy the property, they become the polynomials. And why we do like this, you have come to know. All mathematical convenience. Everywhere we handle the situation as per our knowledge, our convenience, our knowledge is limited. So whatever comfort we want to create, that comfort is our solution. That's all. And therefore the students are what? You are treated the teacher's brainchild. You are a child, but not blood child. You are a brainchild. And in the earlier days, rishis and munis, only they produce their brainchild. The son and daughters of the rishis were getting the education in the same ashram. So own biological siblings, I mean to say the blood siblings, and the other students, they were same. They were given the same title. For example, the Bharadwaj, then Bharadwaj title, the Kaushik title. So, and they were, I mean, at the similar footing. You can imagine that situation. What was the very nice and excellent system that time. And even king was not hiring the teacher. That once you are there in the forest, in the ashram, then king even has to send his daughters and sons. So this is just what? This is a kind of approximation. The brainchild and the biological child, they are same. This is what you will say. They are. This is kind of approximation. Equivalent, not equal, equivalent. So here polynomial is equivalent to function for certain what? For certain purpose. And therefore everywhere you will, this is very interesting issue. This is very interesting issue in the numerical analysis. Most of the cases are being handled by the polynomial, 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 polynomial. You begin with the function and again you come to the polynomial. So, okay, today is enough. I think I just I close the recording first, and then we can do some.